Hi, good morning, my dear students. I'm Daphne. Welcome to my STPM chemistry discussions. I already discussed about the definitions related to different enthalpy changes in my last video. Now, I will discuss how to calculate enthalpy change of a reactions and solve the problem based on past STPM questions. There are several methods to calculate the enthalpy change, but today we will only focus on these two specific formulas. Many students often get confused about which formula to apply. Hopefully by the end of this video, you are able to apply this formula correctly. Now, let's start with the first part, definitions of standard enthalpy change of reactions. Chemical energetic is the study of energy changes that accompany chemical reactions. Whenever a chemical reaction takes place, energy is either absorbed or released. This energy change is crucial in determining the feasibility and directions of the reactions. Before we start with today's topic, let's see the reason why studying chemical energetic is so important. The knowledge about chemical energetic is crucial for predicting whether a reaction will release or absorb energy, which in turn influence how and why reactions occur. Then, we can predict whether reactions will happen spontaneously or not. In industry, knowing the energy changes helps in designing processes that are more energy efficient, saving costs and reducing environmental impact. This is particularly important in industry chemistry, where minimizing energy consumptions can lead to significant cost saving and environmental benefits. There are 3 sections in chemical energetic, however, only enthalpy is in STPM syllabus. Enthalpy cannot be directly measured, so we measure the enthalpy changes instead. The enthalpy change, also known as heat of reactions, represent the difference between the energy used to break the initial bonds and the energy released to form new bonds. In order to determine the amount of heat change in a reaction, we use this formula. If the process releases more energy than it took to start the reaction is exothermic and has a negative enthalpy change. If the enthalpy changes measured under standard conditions with the reactants and products in their standard state, so we call this as the standard enthalpy changes of reactions. Enthalpy changes cannot be measured directly, but they can be calculated from experimental data by monitoring the temperature of a chemical system. However, not all enthalpy changes can be measured directly through experiment. When dealing with reactions that are too dangerous, too slow, involve multiple steps, or present challenges in taking accurate measurements using calorimetry, it may not be practical to perform the experiment in the lab. Fortunately, enthalpy changes can be calculated by using enthalpy data from other related reactions. Therefore, you can calculate the enthalpy change using a calorimetry experiment or Hess's law. In a calorimetry experiment, we measure the temperature change of the reactions. This temperature change allows us to calculate the heat change or enthalpy change using the following formula. By knowing the heat change and the amount of a substance involved, we can then calculate the standard enthalpy change of the reactions by using this formula. In these situations, there are several methods to calculate enthalpy change based on Hess's law. You may use algebraic method. You may applying the formation's enthalpy formula. Lastly, you can calculate the enthalpy change by using bond energy method. According to the definitions of Hess's law, the enthalpy change of a chemical reaction is the same no matter how many steps are involved, as long as the initial and the final conditions are the same. In other words, if you convert reactants into products, the total enthalpy change remains the same regardless of how many steps the reactions involve or which intermediate species are formed along the way. Whether the reactions occur in a single step or multiple steps, the overall enthalpy change is the sum of the enthalpy changes for each individual step. Using Hess's law, the enthalpy change of a reaction can be determined by summing the standard enthalpy changes of formations for the reactant and products. From the questions, we are given 120 grams of water and its temperature increases by 2 degrees Celsius when 0.24 grams of sodium hydroxide is dissolved. We will use this formula to calculate the heat release. Now, let's substitute this value into the equations, and the heat release is 1003.2 joule. Now, let's relate this heat release to the amount of NaOH that was dissolved. The 1003.2 joule of heat was released when 0.24 gram of NaOH dissolved. To determine the number of mole of NaOH, we use the molar mass of NaOH. Since the standard enthalpy change is usually expressed in kilojoule, let's convert the heat release from joule to kilojoule. Next, let's understand what we mean by standard enthalpy change. The standard enthalpy change of a reaction refers to the heat change when 1 mole of a substance reacts under standard conditions. To make it clear and easy to follow, I've organized all the given informations and formations enthalpy value into a table like this. Since the data provided are the value of the standard enthalpy change of formations, we can use this formula to calculate the standard enthalpy change of reactions. This formula is particularly useful for the reactions where the standard enthalpy change of formations of all the reactants and products are known. Write the reactions equations and put the information enthalpy value into the table. It's important to consider the coefficients of the products and reactants. Remember to multiply the coefficients by formations enthalpy value for both the products and reactants. Lastly, we calculate the standard enthalpy change of reactions using the value we obtain and substitute the value into this formula. Now, let's look at some example past year questions related to this formula. I will choose 3 of these past year questions and discuss how to calculate the enthalpy change afterward. Now, let's look at these questions. First, We will calculate the amount of heat absorbed by the solutions using the following formula. Then we substitute the given value into the formula. If a question provides formations enthalpy for products and reactants, you can use this method. It's a faster method compared to the energy cycle, so I recommend it for objective questions. At first, we need to know the chemical reactions involved. The balance equations for the complete combustion of C3H4 is My dear students, before we conclude today's discussions, I want to share some additional information about the combustion enthalpy formula. Although this formula isn't part of the syllabus, you might come across it in some reference books. I've noticed that some students encounter it elsewhere and end up confused between the two formulas. So let's clarify the difference. Now, let's look at these past year questions. I want to show you how convenient is it to use the combustion enthalpy formula to answer an objective questions without drawing an energy cycle. Especially since some students don't know how to differentiate between the formations and combustion formula or find them confusing. In these questions, to make things clearer, we can first organize all the given information into a table like this. Next, we write down the thermochemical equations for the standard enthalpy of combustion of C2H2. Then, that's all for today. Here is a quick take-home message. And don't forget to hit the subscribe button. See you in the next video.